What's the thing with oh yeah. Remember this? What is this? Yeah, stop it. This is like a thing. One of the guys.
All right, ladies and gentlemen, if I could have your attention back up here. Today's notes are arguably probably one of the most important as far as what skills you will need that will be used over and over and over and over and over again in Algebra 2. And then if you go on to pre-calculus or calculus, or if you have to take whatever class you're taking in college, no matter what major you go into, you always are required for one math class to have a credit for. So factoring, it's one of the skills that from Algebra 2 up, it has to be mastered. We're going to practice a lot with it over the next few days. And the first thing I want to direct your attention to are the vocabulary pieces that you need to know. So I want to go give you a basic example, something like this. So this is review. It's specifically review from lesson P5. If you have something like 2x plus 3y, do you remember the vocab from this? Really, the vocab I want to focus on is what is each specific piece called? You guys remember what 2x and 3y are called? There is a constant in there. 2 and 3 are coefficients. That's good. What is 3y? It's separated by addition. Remember what it's called?
Oh,
Yes. Well done, Mario. It's a term. So this would be term 1.
yes.
And this would be term 2. That vocabulary is going to come up today. So make sure you know what it's referencing. More vocabulary that will come up today is a factor. If I look at the term 3y, there would be 2 factors. 3 and y are factors. I know that because they're separated by multiplication. Turn to your partner and tell them what would be the 2 factors of the first term.
2x.
You might have heard Mario, Olivia. It's 2 and x. Well done. 2 and x.
Yeah.
All right, I heard it up here at the front. The 2 factors are 2 and x. The other thing I have to ask you guys is if you have your phone out or something that's a distraction, if you could put it away. I know at the end of the day, phones can be very tempting, but again, this is one of the main core lessons you need in Algebra 2. So I'm going to try to help you focus as best as possible. Okay, in factoring, no matter how many terms you have, notice here I gave you 2 terms, but you'll see in example 3, there are 3 terms. No matter how many terms you have, you always look for a greatest common factor first. And this is often abbreviated as the GCF. These are factoring guidelines. So in these guidelines, I'm going to say look for a GCF first. So look for this first. We're going to be focusing on that today. And that's regardless of how many terms you're given. So I'll just say regardless of how many terms are shown. Then, after you've looked for a GCF, really the way that you factor will be dependent on how many terms are left. If you have 2 terms left, you're going to look for what we did yesterday, the difference of squares or the difference or sum of cubes. So that's number 2. If you have 2 terms, you're then looking for, if you want to just say a squared minus b squared, that rule is called the difference of 2 squares. So you can either write the words or you could write the rule with variables. So look for the difference of 2 squares or cubes, because you could have a cubed minus b cubed. So those of you who prefer to see it just as variables, this one would be a squared minus b squared. This one would be a cubed minus b cubed. And then I'm going to say, or the sum of two cubes. Because although there's no rule for the sum of two squares, there is a rule for the sum of two cubes. Those two pieces we're going to focus on today. On block day after the quiz, we'll come together and talk about what do you do if you have 3 terms or 4 terms. So let's start with taking out a greatest common factor. Do you guys remember what the greatest common factor is?
Like with the number they both go into.
Love it. The highest factor that all the terms share. So I could say the highest factor that divides into all terms evenly if I'm being more mathy, but that's exactly what it is. It's what they share. So go ahead and write it in the highest factor that will be specific, divides into all the terms evenly. Now, I know you guys have heard this before. Factoring is a huge concept in algebra. So let's go to some basic factorings. Number 1, factor out the common factor. What would be, let's just list it first. What would be, it's the highest factor that divides into all terms evenly. Or you could say multiplies into. So if I'm looking at 10, AB, and 5B, some of you might just know it. You might be able to look at it and see what the GCF is. If you don't, if it doesn't just pop out to you, you can do something similar to what you did with radicals. You can factor down each of these. So 10AB would be the same as 5 times 2 times A times B. 5B, there's nothing that can break down further. It's just 5 times B. And you're looking for what's the highest that they both share. Yes, they both share a 5B. So the GCF is 5B, but now I want to use that to factor it. When you're factoring, essentially you're dividing it from both pieces. You don't have to write that step. Mario?
But isn't the 5B negative?
So when I factor it out, I will have to represent that there's a minus in the parentheses. That's true. We don't typically factor out a negative unless this first term is negative, then we'll factor it out. But now if I see what's left, there's a 2A in the first. What's 5B divided by itself? Good. So our answer is 5B times quantity 2A minus 1. If I was checking, hey, did I really get it right? I could multiply it back in and see, did I get the original expression? Which we would. So this factored would be 5B times quantity 2A minus 1. Number 2, on your own, see if you can identify the GCF. All right, look up here, see if you identified it. 5AB would be the highest factor they both share. So now let's make sure that we can factor it well. So if I take out that 5AB, 15A squared divided by 5AB will leave me with a 3A. And negative 35AB squared divided by 5AB will leave me with a 7B. Or negative 7B.
Certain way you need to write it.
Like B times 7 or 7 times B.
The expression.
Like what if it was 7B minus 3?
Ooh, that unfortunately would be incorrect because, yeah, then it switches which one is negative. So we got to make sure that we keep that second one negative. Is it?
Like the only minus.
It's if this was positive, then it would change that to a positive. Yes. Is that not your question? I feel like I didn't answer your question. That was a question. Okay. All right. So this would be our.
Did you know that it had to be 5AB and not just like 5?
Because when, yeah, no, that's true. If I'm looking for what they share in common, so I factored this guy down and I saw that it was 5 times 3 times A times A times B, and this one's 5 times 7 times A times B times B. They both share an A, they both share a B, and they both share a 5. So that's the biggest one that would come out.
So it'd be 5 AB.
Right.
Oh, okay.
Michaela? Yes. All right, looking at this next one. This next one's a little bit tricky at first. Turn to your partner. First thing, why don't you ask them how their day is going? After you've asked them what's one thing that would make their day better, ask them how this particular day is going. And then I'm going to ask the person with the darker colored shirt in the group to share what you think the GCF would be. Olivia, how's your day going?
I didn't look at it.
It's going good. How about yours?
Pretty good. Did you get to play with your dogs today?
How do we do this?
I did, yes.
Hey, makes your day better. Very good. Okay, and then Olivia, I don't know, what color shirt are you wearing?
I'm wearing like a gray with like white stripes with green. I think yours is brighter.
The pink?
Yeah.
Okay. So this one is tricky because like 6 is 3 times 2.
Mhm.
If I look at like this one's just 2 and this one's 3. They don't share anything, all 3 of them. And
Yeah.
it means they all 3 have to share it, but they do all share an XY. So the GCF would be XY. And then if I factor that out, I would have 3x minus 6y plus g.
So if they don't all have like
Thing.
yeah, like the numbers, then you can just keep that inside.
Yes.
Okay.
Yes.
I'm not a teacher.
Well done. All right, guys, let's check this. You should have xy times quantity, 3x minus 6y plus 2. Mario,
Why is it not 6x4y5?
why is it not? Sorry, what?
Well, how'd you get xy?
Good question. So this one is tricky in the way that the number 6 is 3 times 2, yes. But there's no, if I look at this one, which is just 3, it doesn't share a 2 with it, and 2 doesn't share a 3 with it. Essentially, a GCF, I have to be able to highlight the same thing out of all the terms given. So if I broke this down, this one would be 3 times x times x times y. This one would be 3 times 2 times x times y, and this one would be 2 times x times y. So if I'm looking at what's the GCF, they don't share any numbers, not all 3 of them. They do all 3 share an x, and they do all 3 share a y. So the GCF would be xy, and then I'd have to write what's remaining inside of the parentheses. And you can see it here, 3x, whoops, that's supposed to be a blue. 3x is what starts the minus, and then I have 6y, and then I have plus, and then I have just a 2. Good stuff. Any other questions from that one? That type. Okay, the last one, letter 4. Letter 4, if you identify how many terms you're given, it's actually easier to perform this problem. Remember, terms are separated by plus or minus. So I actually have 2 terms here. This would be term 1, and this would be term 2. If I factored those down, x plus 2 squared is the result of x plus 2 times itself. Don't FOIL it because we're factoring. Remember, factoring means unfoil it, like take it out. So if I factored this one, it's 5 times x plus 2. But I am looking for a GCF. So what do both, or I could say minus 5, x plus 2. What would both of these share?
Why was it?
Good, they both share an x plus 2. So since I have that factor in both terms, I can factor it to the outside. So I'll take out that x plus 2, and then I'm going to group what remains.
So the GCF is x.
Yes, the GCF is x plus 2. And then I want to group what remains. So I have the x plus 2 and then the minus 5. So I'm going to go ahead and write those pieces here. So I have x plus 2 minus 5. Now that's good. That's factored. It's not simplified. So if I said factor and simplify, Do you guys see what this could simplify to? Simplifies to. You see something we can combine, essentially. What did you say, Sophie?
Oh, yes.
There's two things we can well, I could distribute a 1 here because there's nothing in front, which means if I distribute that 1, then I would have x plus 2 minus 5. What can 2 minus 5 become? Yeah, -3. So this actually simplifies to x minus 3. And then I still have that x plus 2. So this is factored. This is fully simplified. Caleb.
Okay, so once you FOIL it, the first one, once you FOIL that, it's like an access to,
You don't want to FOIL it.
don't,
No, because when you're factoring, so if I look back at the directions, it says factor, yes, you want to break it down. You don't want to multiply forward.
you just multiply the exponent. No, actually.
You just take out the GCF. So the GCF between this one and this one would be x plus 2. Katie? If I ask you to, yes. If I say just factor, then it's fine. So this, what did this say? This said factor, so this would be fine.
What if you did?
I'd say great. That's well done. Yeah. All right, number 2. We learned this yesterday. You guys did a bunch of multiplying to figure out this rule. Do you remember what a squared minus b squared factors down into? Good. A plus b, a minus b, or if you want to call that a minus b, a plus b, up to you. They're both correct. Well done. Now, do we remember how to use that rule? Let's take a look at this first example, x squared minus 4. First thing we have to look at is what is representing a, so essentially what's being squared, and what's representing b. What value squared gives you x squared? Good. What value squared gives you 4? 2. Good. So as I factor this down, it's going to be a minus b, a plus b, or a plus b, a minus b. So in this case, that would look like x plus 2, x minus 2. And that would be my answer. Number 2 is a little trickier. First thing I would always look for is a GCF. Is there a GCF between 49 and 4z squared? No, 4 is 2 times 2, 49 is 7 times 7. They don't share anything. So the next thing I would see is I see a minus sign and I see a square. So I'd be looking for, is this the difference of 2 perfect squares? Well, let's see. Is 49 the result of something squared? Good, it's 7. Is 4z squared the result of something squared? 2z, well done, you guys. 2z squared does give you 4z squared because 2z times 2z will equal that value. Awesome. So this is going to be my a and that's going to be my b. So as I factor that down of a plus b, a minus b, I would have 7 plus 2z times 7 minus 2z. And that would be it. Any questions before we try the next one? All right, on to what's supposed to be number 3. What's the first step? Always, no matter how many terms I'm given, try to factor it. Take out a greatest common factor. Is there a greatest common factor in this one? Yes, what would it be? 4, good. So if I factor out the 4, I'll be left with 4y squared minus z squared. Now, after I take out a greatest common factor, I look how many terms do I have? How many terms are inside the parentheses? 2. So I would ask myself, since I see a square, does this represent the difference of 2 perfect squares? Well, let's see. Is there something squared that would give me 4y squared? 2y, awesome. And is there something squared that would give me a z squared? Z, nice. So this does match a squared minus b squared. Since there's a GCF in front, I just want to make sure don't lose that. Keep that GCF on the outside and then factor down the a squared minus b squared. So that would look like 2y plus z times 2y minus z. And that would be my answer. Just leave the 4. It's a GCF, it stays on the outside. What is it? Greatest common factor, yes, and it's 4 in this case. All right, on to the most advanced type example, letter 4 of this type. Is there a GCF? No, so the next thing I would ask is, I see, this is tricky to see, but this is actually a square. And the number 1 is actually a square. What value squared would give me x to the 4th? Nice. And what value squared would give me 1? Nice. So a is being representative of x squared, b is 1, a minus b, a plus b, or a plus b, a minus b, however you want to write it, would be x squared plus 1, x squared minus 1.
Does it matter if which the order it goes in?
Nope, you could do minus first, plus second. Now, when I'm here, I want to stop and say, okay, here's 2 terms. Do these 2 terms match the rule a squared minus b squared? No, because there's a plus sign. Do these 2 terms match the rule a squared minus b squared? Well, let's think about it. If I think about a squared minus b squared, they have the minus, and they're both squares. It's just kind of strategic in how you have to see it. What value squared would give you x squared? X. What value squared would give you 1? 1. So this does actually still match the rule, which means I still have to factor it further. So what does x squared minus 1 factor down into? X squared minus x plus 1, x minus 1. Good. And then I do have to bring this down with it. I can't just take it away. So this final answer would be like this. X squared plus 1 times x plus 1 times x minus 1. That's the most advanced type you would see of this format, where you're factoring 2 perfect squares. All right, let's move on to the second rule we learned yesterday, or that we discovered yesterday by doing a bunch of multiplication. The difference of 2 cubes and the sum of 2 cubes. Do you guys remember how both of these factor down into a binomial by a trinomial? SOAP is what we're going to use to help us remember how the signs will work. It worked for difference and sum, which is actually helpful. Caleb? Yes. Caleb, do you remember how the A's and B's work?
The A's and B?
Yeah, like what this rule is?
I bet I do.
Okay, let's do it. Just before you leave.
I bet I do.
Can you tell me before you leave?
The A's and B's?
Yeah, or how they work.
Basic example.
So there's a rule that we learned yesterday. A cubed minus B cubed factors down into something with a bunch of A's and B's. It's not A minus B, A plus B.
Nope, no, you can't go through that one. Sucks.
I actually go that.
All right, when you come back, you need to make sure to copy this, okay? Caroline, do you remember?
Don't
Like,
get
you get-
it would be A minus,
Nice.
and then it would be A squared plus A times B,
Well done.
and then plus B squared.
Woo! Nice job, Caroline. Well done. You are one of the first people that has gotten it right first try almost all day. So I am going to, I'm going to give, do you want some panda cookies? I have to give you a treat. I've been walking around all day and it's been tough. It's been a struggle today. Let's see, guys. I might walk around with more candy. Can you get the sum of 2 cubes after Caroline's help?
Oh, I got you. Wait, I got it.
Raise your hand. I'm not. This is sad. Okay. All right. Let me walk around with some candy because it's the end of the day. And candy is one of the things that makes my day better. All right. Let's see. Raise your hand if you got it. The sum of 2 cubes. And I'm sorry.
I swear if I get this wrong, I'm gonna cry myself to sleep.
Oh,
You get A squared minus AB plus B
you
squared.
cannot argue about what candy you get, but if you have it correct, I will give you a piece of candy.
Here, I
Well done. No, That's correct. Well done. Well done, if it's correct. Well done.
Wait, I just realized.
I
did A plus B, and then A squared minus AB plus C.
Well done.
Can't be for you.
Very, very close.
Oh, great, okay, now it's not fair.
Yep, sorry.
I was unaware of the color, right?
Well done.
Caleb doesn't get it. Don't give it. Don't give it. Do I get it? You go to the bathroom. I'm gonna have to go to the bathroom.
Wait, so something plus B,
Still make it.
A squared minus B
I see,
plus B
isn't the last one
squared.
class?
Yeah, you
Is this the last one? I actually just.
Like Mark, like,
Oh.
I got that. I was kidding.
Wow. I had that first and then I was like, no.
It's gonna be on my grade.
Alright, hopefully I'll make it a little bit better.
Like I'm gonna have a voice recording.
Alright, guys, I'm sorry, Olivia, I can't give you candy through the screen. Here we go. You need to remember that this is the same sign as what you started with, plus. Then it's the opposite of what you started with, minus. The last one is always positive. The A's and the B's match exactly what Caroline told us. But then it's same, opposite, always positive. And we learned that yesterday, so I'm not going to focus too much on that, except for do you know how to use it with maybe some more advanced type examples. So let's try it with the first example, example 1. I have 2 terms. My first step would be, is there a GCF? No. So the next thing I would notice is I have a cube. So I want to see, do I have 2 values cubed? What times itself gives me x cubed? Good. And what times itself gives me 8? 2. So this is representative of A in the rule, and this is representative of B in the rule. And I'm just going to plug and chug into what I wrote above for the sum of cubes. So that one right there. So I'm going to have x plus 2 times quantity x squared minus 2x plus, what does 2 squared become? 4. And that's it. That's the answer. Okay, on your own, try it with x cubed minus 27.
Actually, do not think I did that right. I think I got it.
All right, let's check. You should have quantity x minus 3 times quantity x squared plus 3x plus 9. And last one I want to do with you is at least number 3. Number 3, is there a GCF between 8 and 27? No, you're right. 27 is 3 times 3 times 3. 8 is 2 times 2 times 2. So no GCF. So then I notice a cube. So I want to see, is this the result of something cubed? And is this the result of something cubed? What cubed gives me 8x cubed? Nice. What cubed gives me 27y cubed? 3y. Now I'm going to write this rule again, even though hopefully you're getting it better by now, because this one's a little tricky in how to fill in. So a minus b, a squared plus ab plus b squared. You all have already figured out what a and b should represent. So let's go ahead and let's pop these in. A is 2x, b is 3y. Here's the piece that's you have to be careful with. When I square a, I have to square all of 2x. And when I square b, I have to square all of 3y. When I multiply them together, what's 2x times 3y? Good, 6xy. So now let's clean all of it up. This is going to become 2x minus 3y times, this is where we have to just think about it. What is 2x times itself? What is 2? Good, 4x squared. Maybe it's not as tricky as I thought it was. But 2x squared is 4x squared plus 6xy plus, what's 3y times itself? Good, 9y squared. All right, here's the thing. This, although muy importante, is not, oh yeah, using Spanish. It is not on the quiz. It is homework. Homework is to do this homework from the book and study for the quiz. 2 pieces for 2 nights. This is not part on the quiz. It will be on the test, but is on the homework.
Number 2.